Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make the tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here is a problem for today for exam MFE. Consider a 9-month dollar-denominated American put on British pounds. You are given that the current exchange rate is 1.43 US dollars per pound. The strike price of the put is 1.56 US dollars per pound. The volatility of the exchange rate is sigma equal to 0.3. The US dollar interest rate continuously compounded is 0.08 or 8%, but continuously compounded. And the British pound interest rate continuously compounded is 0.09. Using a 3-period binomial tree, calculate the price of the put. The total length of the period of time until option maturity expiration is 9 months, which is 3/4 of a year. When we are doing 3-step binomial trees, so each step will be of the length of the total time, t, of 3/4 divided by 3, so 1/4 of a year. We will compute U and D, the values of a dollar invested in the risky underlying asset after the up move or a down move in this model in one step. The risk neutral property of an up move P star and the risk neutral property of the down move 1 minus P star. So U is equal to e to the R minus RF H plus sigma square root of H. So H is the length of the period of time. Sigma is the volatility. R is the risk-free interest rate on the domestic currency. So basically the underlying risk-free interest rate. RF is the interest rate on the foreign currency, which is basically treated like a stock that pays a continuous dividend at the rate RF. We plug in all the numbers and we get this to be about 1.158933. D is the same expression but minus sigma square root of H, and now again we plug in all the numbers, we get 0.858559 approximately, but that's good enough for the purposes of this problem. And P star is equal to e to the R minus RF H, so basically risk-free rate of return, 1 plus the risk-free rate of return after adjustment for the dividend, so X dividend. Now that, of course, the rate of return on the foreign currency plays the role of the dividend here. Minus D divided by U minus D. And that is approximately 0.426. That's the risk-neutral probability of the up move in the underlying. And 1 minus P star is the risk-neutral probability of a down move in the underlying. And then we'll draw the 3-period binomial tree for exchange rate. In a moment I'll show it to you. And in that tree you'll see that numbers within parentheses will be the payoffs of the put option if exercised. So here is the picture of that. And we have these values are simply the previous value of the underlying multiplied by U for the up move and by D for the down move. And underneath it, you have the value of the exercise of the option at that moment in time, at that node of the tree. So of course it's a put, so you see that the option becomes valuable when exercised for the mostly downward moves of the exchange rate. The payoffs of the option at maturity at option expiration, time 3h are in the down, down, down node after 3 down moves, 0.655. down, down, up, which ends up in the same spot as down, up, down, or down, up, down, down, is 0.3384. Down, up, up, or it's the same ending spot as up, up, down, or up, down, up. The payoff is 0. And up, 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 the payoff is 0. And now we calculate values of the put at time 2h for various states of exchange rate. We'll first calculate the value based on the future payoffs from this general formula that it's the actuarial present value, basically discounted at the risk-free rate, future payoffs, which are taken after being multiplied by risk-neutral probabilities. So it's the expected present value and the risk-free rate and the risk-neutral probabilities. In the up-up move, that's basically expected present value of a weighted average of 2 zeros, so 0. For the up-down move, well, that's going to be e to the minus 0.02, which is 3 months, a quarter of a year. Annual rate is 8%, so 0.02 continuously compounded per quarter. And then for the probability of the up move, 0.426 multiplied by PU du, and 0.5374 multiplied by PU dd. So we have approximately 0.1783. And for dd, we use the same method, basically expected present value under risk-neutral probability and using the risk-free rate over the period from the two nodes that this PDD leads to, so PDDU and PDDD. And that turns out to be approximately 0.4985. Since the option is American, we should compare these with the values of the option if it is exercised at time 2h, which are 0, 0.1371, and 0.5059 respectively. And as you see, 0 and 0 doesn't make any difference. The two values are the same. 0.1783 is bigger than 0.1371, so it doesn't make sense to exercise the option. But in the down node, the value of the exercise is 0.5059 versus the value based on future cash flows being 0.4985. So exercise is what makes sense in this case. So, as I just said, in the UD node, we keep the value of 0.1783, but PDD is the value of exercise, so 0.5059. Now we calculate values of the put at time h for previous set of states of exchange rate, so PU and PD. Again, as the expected present value using risk-neutral probabilities and the payoffs of the future nodes. And that turns out to be, for PU, it's 0.0939, and for PD, it's 0.3474. The option is American, so again, we compare this with the values of the option if it is exercised at that time, which are 0 and 0.3323 respectively. Both of these are smaller than the values based on the future payoffs, so we keep these two values as the values at these two nodes. And then we compute the time 0 value of the put based on those future payoffs. It turns out to be 0.2256. The value of immediate exercise is 0.13. This is a bigger number. It's not optimal to exercise at time 0, and the price of the put is 0.2256, approximately, because we did some rounding in the process. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries and belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.